Okay, so now we'd like to work on taking a context-free grammar and attempting to identify the language that it generates. So here we've got S and the four production rules. It can be replaced with AS, SB, A, or B. And we'd like to try and determine the language that this represents. So one way to do that is just to write out some strings within the language and see if you can identify a pattern. So certainly because S returns A and B are going to be the language. What else can we obtain? Well, if S goes to AS, I can replace that S with an A. I can get double A. S can go to AS, and then I can replace that S with a B, so I can get AB. It looks like I can always go ahead and place A's on the left and B's on the right in an arbitrary manner. So you have like S goes to AS, SB, AS, SB, etc. So the only way I can construct strings is by adding A's onto the left and then B's onto the right, and then terminating eventually with either an A or a B. So it doesn't look like it's possible to produce a string that contains BA as a substring. Not possible to have BA as a substring. And so the only strings I can produce here, just by sort of intuitively looking at the past trees that can be produced, it's going to be A's on the left and B's on the right. So it looks like the language here is going to be some number of A's, some number of B's. What restrictions can we have on N and M? Well, it looks like I can always shove in arbitrarily many A's on the left for free, and shove in arbitrarily many B's on the right for free. But it looks like I can't make the empty string, right? It has to be at least a single character, which means N is greater than 0, or M is greater than 0, because at least one of the two has to be bigger than 0. A and B alone can be generated, but epsilon can't. So that means we have this property here. Again, you don't need to formally prove it, you just sort of like intuitively argue why this is the language.